Today's lesson is on verifying trigonometric identities. Okay, so my learning objective is I can verify trigonometric identities using algebraic methods by simplifying the left side or the right side to equal the other side. So for a warm-up, I want you to give me the basic 8. Can you pause the video and put in the basic 8? All right, so I got CSC of x equals 1 over sine of x, secant of x equals 1 over cosine of x, cotangent of x equals 1 over tangent of x. So these are the reciprocal, the ratio, the tangent of x equals sine of x divided by cosine of x, and cotangent of x equals cosine of x divided by sine of x. Those are the ratio. And then the Pythagorean are sine squared of x plus cosine squared of x equals 1. 1 plus cotangent squared x equals cosecant squared x. And 1 plus tangent squared x equals secant squared x. Okay, so these are the basic 8, and we should be intimately familiar with working with these for a while now. Okay, so let's go through some guidelines. What is it we're trying to do? When we are trying to verify something, I'm going to make mistakes. This isn't something you get right once, so make sure you're using pencil so you can erase. You're only working on one side, and you want to always pick the more complex side because you're trying to simplify it to equal the other side. So don't pick the simple side because there's nothing to do with it. So we're going to look for algebraic manipulations. We're going to need to be adding fractions, so we'll get common denominators, factoring, we'll be multiplying out. We're going to be doing some substitutions, using the basic 8 a lot. A lot of times I think about writing in terms of sine and cosine, and I'm thinking a lot about squared terms, especially if they have a 1 with them, to the Pythagorean identities. And you just keep working one side until you equal the other side. All right, so what's one of the goals? So let's just look at something a little less complicated first before we get to trig. All right, so my goal is I want to get everything multiplied out because anything divided by itself is 1. So in this first scenario, this is what I want. I have everything multiplied out. So if I would rewrite this, I could rewrite this as x over x, 5 times 2, and 3 times 11, right? And x divided by x, anything divided by itself is 1. I can rearrange. The biggest mistake I see is I am not multiplied out. Do you see how I'm adding here? But what I see students do is simplify these x's, and that is not appropriate. So I cannot simplify like this. So your goal is I want to be multiplied out so that I can rearrange my multiplication. So anything divided by itself is 1. So these would simplify out. That is what I'm trying to do. All right, so let's go do that with some trig terms. All right. So verify each side. So what I'm trying to do is I just work on one side and I leave the other side alone. Okay, so I'm going to pick the more complicated side. So I am going to pick on this one, I'm going to pick the left side to work with. So I'm going to rewrite tangent in terms of sine and cosine. So tangent is sine of x divided by cosine of x. And then this is going to be divided by sine of x, and I don't do anything to the right side, so I just leave the other side alone. So this is just secant of x. So now I'm dividing fractions. So to divide fractions, I flip and multiply. So this is going to be sine of x divided by cosine of x. So this is really sine of x over 1. So when I flip it, it is 1 over sine of x. And that equals the secant of x. So at this point now, I am all multiplied out. So I have sine of x divided by sine of x. So that simplifies to 1. And now I'm going to rewrite 1 over cosecant as secant of x. So this is secant of x, and that equals secant of x. So when I get my left side equals my right-hand side, I put a check mark next to it, and that's the symbol that I have been verified. Okay? Well, and number 2. Let's look at number 2. So I want to take the more complicated side and choose that and simplify it. So I'm going to pick the left side again. It doesn't have to be the left side, but I'm going to pick the left side. So tangent of x, I'm going to rewrite in terms of sine and cosine. So this is sine of x divided by cosine of x plus cotangent, which is cosine of x divided by sine of x. So I rewrite in terms of sine and cosine. And then I'm going to leave the right side of the equation alone. So 1 over sine of x cosine of x. So I'm adding fractions. So when I'm adding fractions, I need a common denominator. So I'm going to multiply by 1. So when I multiply by 1, I'm getting a common denominator. So now I have sine times sine is sine squared of x plus cosine times cosine is cosine squared of x all over my common denominator, which is sine times cosine. And then I didn't do anything with the right-hand side, so this is 1 times sine of x times cosine of x. And now I can substitute with the Pythagorean identity that sine squared plus cosine squared is 1. So I'm left with is 1 over sine of x, cosine of x. And I didn't do anything with the right side, so 1 times sine of x, cosine of x. And when I have my left-hand side equal my right-hand side, I put a check mark to show that it has been verified. Let's try one more. Okay, let's choose what's the more complicated side. I think it just happens to be the left-hand side again. I don't really have anything to simplify with 1. So I'm going to substitute first. So 1 plus tangent squared is secant squared of x times cosine squared of x. And I don't do anything with the right-hand side. I'm going to rewrite secant squared as 1 over cosine squared. And cosine squared of x equals 1. Since I'm multiplied out, I can simplify. So I have a cosine squared and a cosine squared. So I have 1 equals 1. Left-hand side equals the right-hand side. So I have been verified. That's it. I only work on one side. I choose the more complicated side, and I keep going until I am exactly equal to the other side. And my goal is I want everything multiplied out so I can simplify by rearranging anything divided by itself as 1.